Okay, great. All right, so I'm going to share the screen. So 10-5, number 5.
Yes.
So let's see what we got going on here. Consider the line which passes through the point 5, -5, -3, and is parallel to the line that you see there. The line they give you is x equals 1 plus 6t, y equals 2 plus 5t, z equals 3 plus 7t. The only thing you really need to peel off of that is the vector that it's parallel to, the 6, 5, and 7. The 1 and the 2 and the 3 are just, it's just another point that that line goes through. So we can ignore that. All right, so you know what I'm going to do. So let's see. We want to find the intersection of the new line with each of the coordinate planes. All right, cool. So I'm going to stop the share, and I'm going to change my camera here. And then let me get this nice and big. Alrighty. As usual, I'm goofing around with the lights here. Let's see if this helps. We'll try it out. So our line is going to be composed of this information. It's going to be x equals 5 plus 6t, y equals -5 plus 5t, and z equals -3 plus 7t. Okay? Make that look like an actual 6. There we go. And then, so again, interrupt me if you have any questions. I just basically built the line based off of this pass-through point and the parallel vector. I'm gonna make sure I read that problem correctly. Yeah, I read it right. All right, cool. All right, so we want to find where does it pass through the XY plane? Well, that happens when Z is 0. So what we do is we take the Z equation here and we set it to 0. And you get T is going to be 3/7. Okay. And then you just go back in and you plug 3/7 into the X and Y to get the coordinates. So X will be 5 plus 6 times 3/7. Y will be -5 plus 5 times 3/7. And what do you get? 5 plus 18. So now, to be honest, you could probably leave it like this. It'll probably be accepted. And of course, Z is 0. We took that care of that first. If you wanted to clean it up a little bit, let's say it'd be 35, that'd be 53/7. And this would be -35, -20/7, and then 0. And then you do the same thing for the other ones. So for the XZ plane, you set Y equals 0. And for what's the other one? The YZ plane, you set X equal to 0. And you just run through the same routine.
Yeah, that's what
For
I had done. For some reason, then I had not gotten the right answers. It might have been a data entry mistake on my part. I'm going to try that again.
Okay, if you're getting errors, if you swear you've done it right, put it to Ed discussion with over the screen capture. Let us take a look and we can maybe diagnose it.
Okay, thank you.
And the
uh,
other one you wanted to look at was number 10, right? So before I move off of this one, is there any other questions on this one?
yes, sir. Could we write that as 1/7 times the vector 55 comma -20 comma 0?
It'd be 50. Actually, I got that
Sorry,
wrong.
57. Yeah.
No, hold on, 35. That should be a 53, actually. So 35.
Yeah.
Yeah, that's a 53. Yeah, yeah, you could do that. It'd be 1/7. Well, it'd be a point. Why not? Try it out. See what affinity accepts.
Why does that become a point and not just a scalar multiple of a vector?
Well, because the question was asking where does it intersect the XY plane in this case. So it's a point. But
Okay,
in
thank
reality,
you.
you can switch back and forth between them pretty much at will.
Mhm.
So it really qualitatively is not much different. There's really no difference.
Thank you.
Okay. Let's take a look at number 10. So let's see what that one's all about. I'm going to share my screen. All right, let's what we got going on here. This is 5, number 10. Determine whether the lines that you see there intersect, are skew, or are parallel. If they do intersect, where do they intersect? So let me write down the information here, and again, I'll share my screen. Well, I'll show you what I got. We've got x equals 17 plus 4s, y equals 1 plus 2s, and z is 18 plus 6s. Meanwhile, we got another line. X is negative 5 plus 5t. Y is negative 13 plus 4t. Z is negative 18 plus 9t. And the unshare. All right, so a couple comments here. These are two separate lines. So we use two different parameter variables. One gets the letter S, one gets the letter T. They're independent parameter variables. That just avoids confusion. So what we're going to do is we're going to try to force an intersection. If that happens, that means that we should be able to set them all equal to each other and get an answer. I should be able to set like the x's equal to each other, the y's equal to each other, and the z's equal to each other. And it should work out. So let's find out. Let's just see what happens. So what I'll do is I'll do a little simplification. Let me get the variable quantities to the left side. So it'll be 4s minus 5t, and then I'll move the constant over. So it'll be negative 22. Here I'll have 2s take away 4t, move the 1 over, it's negative 14. Here I have 6s take away 9t, and move the 18 over, that's negative 36. And as usual, I got to make sure I didn't make a stupid error. So let me double check myself. I think that looks good. All right. So far, so good.
Okay, that was a different approach to what I did. I added up a system of two equations before trying to move things, but
Well, that's what you're going to do because the problem here is that we've got what's called an over-described system. It's got three equations and two variables. And usually they don't work, but we don't know that yet. So what I'm going to do is I'm going to take the first two and work them out. Let's do it down here. I should be able to get the first two to work out. No problem. It's a 2 by 2 system. It doesn't look singular. It should work out. By the way, you'll have access to the matrix calculator on Desmos on the test. I don't care how you solve this. Um, it's really up to you. In fact, I'll tell you what, I'm just gonna throw this on my calculator if you give me a moment here. Actually, you know what? Do you guys know how to use the matrix calculator in Desmos?
I I have not used that before. Is that going to be available on the exam?
Yes. In fact, why don't I do that? Why don't I do this one on the Desmos?
Yeah,
So
I would really appreciate that
it'll be
demonstration.
like a demonstration of Give me a second here. Let me go to it. All right, so I'm going to go to Desmos now. I'll come back to this page here when I'm done. So here's the Desmos calculator screen. I'm going to type new matrix, and my system is actually has three columns, so I need an extra column. And what I'm going to do is I'm going to type in the coefficients and the constants of the system. Now, if you recall, it was 4s take away 5t equals negative 22, 2s take away 4t equals negative 14. And so I enter it. Now, what I do is I go down here to RREF, which is reduced row echelon, just type in letter A, and bada boom, there's my answer. So I've got a matrix that goes 1, 0, negative 3, 0, 1, 2. And what that implies is that this is S. So S is equal to negative 3, T equals 2. So I'll pause there. Did everybody catch what I did on that? That's how you solve a system quickly.
I I I don't I don't understand the matrix algebra behind it.
Well, you don't have to. It's a lot of uh, it's a lot of matrix algebra steps. Normally, something like this by hand would probably take about 5 minutes. But what you're doing is you're turning this system here into what's called a reduced row echelon form. That's what the RREF stands for. And you're doing
And
that through basic matrix arithmetic. You don't have to necessarily understand that to get the numbers. You can always solve a system by using substitution and elimination, the old-fashioned method. So whatever method works for you. But I will allow
okay.
this on the test, so you have it if you want to practice it.
Okay.
Hey,
Okay.
Sam,
Yes.
the easiest way to think about it, if you took that first column 1, 0 and multiplied it by S, and that second column 0, 1 and multiplied it by T, you'd end up with, 1S plus 0T equals negative 3. So
Okay.
that third column is the value of your parameter that you got there.
Okay. Okay. Um, I'm
I'm gonna
going to have to do some more reading about this. But
Yeah,
thank you
practice it.
very much.
Practice it. All right, so here's where we stand with the problem. Let's go back to the original. We actually have three equations governing each line. So we actually have six equations. And what we did was we set the x's equal to each other, the y's equal, and the z's equal. We cleaned it up a little bit. I took the first two and solved it as a 2 by 2 system, and I got an answer. That only works out for the first two. What I need to do is I need to check this answer in the third equation, the one I didn't use. That's this guy down here. That's 6s take away 9t equals negative 36. Now this is just a question of, is it equal or not? Is it a true or false outcome? So I'm going to plug in the negative 3. So it's 6 times negative 3, take away 9 times 2. And again, question mark equals negative 36. It's negative 18, take away 18. And sure enough, it is true. It works. That tells us that these things actually intersect. They're not parallel. We can tell they're not parallel because their direction vectors are not multiples of each other. And so they intersect. Now, if this had failed, let's say I checked the answer in the third equation and it failed. Let's say that was a negative 35 right there, and I get negative 18 minus 18 equals negative 35. That's a false statement. That means the lines do not intersect. They would be called skew, S-K-E-W. In this case, they actually did work. So negative 18, negative 18, negative 36, it works great. So the question then is where do they intersect? So you take your parameters that you got here, and you just go back to the original functions at the top and you just plug them in. So for example, if I plug in negative 3 up here for S, so for line 1, Let's do 17 plus 4 times -3. That's 17 take away 12, which is 5. 1 plus 2s, well, again, 1 plus 2 times -3, that's 1 plus -6, which is -5. And, I'm sorry, and then z is 18 plus 6s. Well, s is -3, so 18, well, that's going to be 0. Okay, so evidently they intersect at 5, -5, 0. You can check it if you want by doing line 2 and using parameter t equals 2. Let's try it out. Um, so I have x equals -5 plus 5 times 2. Well, that's -5 plus 10, which is 5. Y equals -13 plus 4 times 2. That's -13 plus 8, which is -5. And z is equal to -18 plus 9 times 2, which is -18 plus 18, which is 0. And sure enough, we get the same answer. And there you go. So there's a lot of math going on here. Um, Everybody, any questions on that one?
Thank you. That
Sure. Okay, great.
Um, so I like don't have it with me. I have it written down and that's what I have written, but I don't have an example. So I guess to explain when we plug values into that, when we're doing like cross product,
Okay,
um, we do I and then it's minus whatever value in front of J and then
correct.
plus K. So in some of the homework questions, it would give an equation with like plus J. And so I would assume that would mean the value was negative. But then it would end up, I would be mixing up the positives and negatives. But if I see a positive J in an equation, that usually means the value should be negative, correct?
Well, let me, let me, let me, I don't want to give you an all one size fits all answer.
Okay.
I'm gonna, I'm gonna make up an example here. I'm just gonna make up a couple of vectors. This is a cross product. The vectors are 2, 1, 4, -3, 2, 5, let's say. And what you do is when you're doing the expansion, you're doing what's a method called minors and cofactors. The minors are the 2 by 2 submatrices. For example, the minor of I is found by covering up the row and the column. You just cover up the row and the column, and that's the minor of I. So the minor of I would be 1, 4, 2, 5. The minor of J, you cover up the J column and you take what's left over, so 2, 4, -3, 5. And then the minor of K is going to be 2, 1, -3, 2. Those are the minors. The cofactors are actually the signs in front. And you may, if you've ever done determinants, you've seen what's probably called a cofactor matrix. Looks like a checkerboard. This is called the cofactor matrix of a 3 by 3. And we're expanding along the top row. And that means that this minus sign is an automatic. It needs to be there. Okay? That doesn't mean that your coefficient of J will necessarily be negative. It means that whatever you get when you work out the minor here, this minus sign then attaches to it. So if this works out to be negative, then this minus sign will make the whole thing positive. If this turns out to be positive, the minus sign will make it negative. Okay? Um, so let's work this out since I've got it going here. Here I have 5 take away 8 is -3. Here I have 10 take away a -12. That's 10 plus 12, which is 22. Then the negative attaches. So in this case, it's -22. Here I have 4 take away -3. That's 4 plus 3, which is 7. All right, this is the cross product of these two original vectors. Now, if you're still unsure whether you did it right, I recommend that you check your answer by dotting the cross product with the original two vectors. So for example, if I dot my -3, -22, 7 with 2, 1, 4, well, let's see what happens. I get -3 times 2 is -6. -22 times 1 is -22. 7 times 4 is 28. And when I add them, I get 0. And that should happen. That tells me I'm doing it right. Let's try it with the other vector. So -3, -22, 7, dotted with the other vector, -3, 2, 5. So I have -3 times -3 is 9. -22 times 2 is -44. And then 7 times 5 is 35. And sure enough, 9 and 35 make 44. 44 take away 44 is 0. So it worked out. The cross product is a vector orthogonal to both of the original vectors. This is a great way to check your work. Okay.
Yes. And so when you have that final vector, right, the -3, -22, 7,
Uh-huh.
you were to write that in the equation with including ijk, you would write -3i plus 22j
No,
plus
no, write it just as you see
7k.
it. Just write, no, write it as you see it. In this case, the negative is included.
Okay, that's where I was getting mixed up. Sometimes if I had a negative value, because there was the negative involved in the cross product, like it was attached to it, I would apply it when writing it out after the fact and make
Yes,
that a positive.
yes. You take care of this negative right at this step.
Right. And then you forget it after that. It's
Yeah, you
already
just let,
applied. You don't need to adjust it, right?
right.
Okay, thank you.
Sure, not a problem. Good. So this was question number 34 from the practice test. I'm going to just share the screen very briefly. It's this one right here, the projectile motion. And then I'm going to unshare, and I've copied down the information. I integrated a couple times to get the velocity vector and the displacement vector. So the question asked the range. That's how far does it go? Okay. So I ask you guys, this is where you kind of have to think about, you have to kind of see into it a little bit. So when the object is shot from ground level, its initial height is 0, and then it goes into the air, of course, and then it comes back down. When it comes back down, what is its height? So when it lands, its height should be 0, right? So we'll set the second component equal to 0. Now in this case, I can factor out a t and check it out. You get two answers. You get an answer of t is 0 because that's when it was shot. And then when we work this out, which is just a linear equation, that's going to be 350 divided by 4.9. We get 71.428. Now that's seconds. Okay, that answers the when did it land? It landed 71.428 seconds later. So to answer the question of how far away did it land, we have to take that 71.428 and hold on, I'm confusing myself. Give me a second here. Oh, no, no, we're fine. We're fine. I plug it into the x component. So I want to know how far away. That's my horizontal distance. So the height is 0. The horizontal distance will be this guy. So the question is its horizontal range is the 606.2 times the 71.428, And that will give us the distance. It's gone quite a ways. 71.428. It's, wow, 43,299.65 meters. Jeez. This thing is like supersonic. That's 43 kilometers. Wow. All right. Huh. Sorry about that. Does that make sense?
Yeah.
So I've always told people just build out the equations, get them all built out, and then you should be able to infer what you need to do. It's, this is one of those things where there's probably like about 3 dozen different ways the questions can be asked. So it's really hard to summarize into a purely formulaic process. A lot of times you have to kind of see into the problem. So when it asks for the range, you kind of have to say to yourself, well, it's shot in the air, then it comes back down. When it comes back down, its height will be 0. So I set the height to 0, solve it. I get this, the 71.428 seconds. That gets plugged into here to get the horizontal movement, which is what you see here. Okay, let's go ahead and finish this one off. The maximum height of the projectile. Well, okay, max height would be, there's a couple ways to do this. You could just treat this as the parabolic trajectory here. I'm wondering, you know what? Actually, I'm going to go with here, but I think it still works either way. The object reaches its max height. When the object reaches its max height, its vertical velocity will temporarily be 0. Would you agree with that? So I'm going to
Yes,
find
that's actually how I started this one instead of doing the range. I started with that.
Let's figure it out. So when the object reaches its max height, its vertical movement goes up, then down, but there's that split moment there where it stops. It's 0. So I'll set the vertical component of velocity equal to 0. That'll give me a t value, which, again, I'll get the calculator out for that. 35.714. And by the way, you probably recognize that that number is half of this number, which that's what I was going to do. I was going to work out the vertex of this, but it's just easier to use that. That's going to be seconds. So the max height, this is the when it reaches its max height. So to find the max height, we got to take this 35.724 and plug it into the vertical component of displacement. So that would be negative 4.9. And then this number, 35.714 quantity squared plus 350, 35.714. And I guess that's all. Let me work that out real quick. Making sure I type it in right. I get, no, I screwed it up. What did I do? Oh, I typed it in wrong. That's what I did. There we go. I get 6250. That would be meters. So this thing is really being shot fast. This thing is 6 kilometers into the sky. All right. Any question on that one?
If the object had been thrown from a building with an unspecified height, how would we go about what's the proper way to go about finding the height?
Well, okay, again, you'd have to have some other bit of information to be able to solve for the height of the building.
Okay.
You would have to be able to work backwards. So you might be given some information that says that the object landed at 72 seconds. So you would
Okay, cool.
you'd be able to
We wouldn't
work
have to do
back.
that from this kind of equation, right?
No, in this particular equation, without knowing the initial height, we wouldn't be able to solve the problem. So you should be given just enough information to isolate the necessary variable. if you didn't know the initial height, if the problem actually said unspecified height, just give it like R2. And then somewhere along the line, you're going to have to solve for that. You'll use it in some other, like what you did here, and then hopefully isolate that variable.
Okay, got it. Thank you.
Sure. And then the last question is the speed with which the projectile hits the ground. Well, I'll just verbalize it. We know that it hits the ground at 71.428 seconds. So I take that value and I plug it into the velocity vector at that value. Now it doesn't change the first part, but it will change this. I'll just go ahead, let me just go ahead and write it. 9.8, 71.428 plus 350. Let me work it out real quick since I'm going ahead with it. I'm just gonna okay, it works out to be 606.2. This actually works out to be negative 350. Is that right? Yeah, that would make sense because it's coming down. All right. That's the velocity. So this is when it hits the ground. This makes sense. It's moving horizontally always at this value per second. It's coming down at this rate, negative 350 meters a second. And so the speed is the magnitude. Now the negative will square away. And actually it worked out to be, I get 699.98. I bet you that comes out to 700 meters per second. And that makes sense. Since this is a symmetric situation, you would expect it to come down with the same speed that it went going up. And in these problems, we ignore air friction and spinning of the object. We can actually make it move oddly. So we assume perfect parabolic motion. Pretend this is on the moon. All right. Does this help? Gawain, this was yours, right?
Yeah, I basically went about it the same way, except for I did the height, I did velocity 0 first, and then kind of went backwards from there. But I just preserved all of the radicals and fractions until the end, so I think that's why mine was getting real messy towards the end.
Well, and this was getting messy too. I was trying to take it out to 3 decimal places, and even then, it gets a little messy. So you just have to, yeah. I think it's messy no matter what.
Cool. Yeah, I just wanted to see if there was any other steps I should have done in between to make it a little easier for me. But
there's probably more than one way to do this particular question. This is just the way I happen to see it. So with these questions, so the general rule or the general suggestion on any of these projectile motion questions is to get we always get the acceleration. That one's easy, but get the velocity and the displacement vectors set up. Get them complete and set up. These two guys right here are what you need to break into the problem. And then how do you break into the problem? This is where you have to have some insight. And again, if I use this problem, when it lands, the height will be 0. So that's how I break into the problem here. And then from there, I work it out. I know that you've probably seen equations from physics classes. And one thing about physics books that I have discovered is they love formulas, don't they? And you might get about 25 separate little formulas for just projectile motion alone. They're trying to cover every conceivable scenario. Trying to memorize that many formulas is difficult. If you can set this up and then again somehow use insight to kind of like crack the egg, you should be able to work them out. I have a bunch of examples on my notes on my website. I don't have every conceivable example, but I have a bunch if you wanted to read a few.
Actually, I was gonna refer to that, the question about, what if we have something thrown from the top of a building or top from a cliff? If you example 22.1 in the typed examples for 10.9 covers that, but basically what you're going to do is you're going to treat the height of that building as r sub y. So you're going to add it to your what's called your y component of the vector.
Right.
So
That would
yeah,
go right there. And by the way, you
yeah,
always can set your r sub x to 0. You can always
yes.
superimpose an XY axis system such that the object is released where the initial horizontal displacement is 0. And
So if we were to do the same thing thrown off of a 100-story or 100-foot building, then it would just be negative 4.9 t squared plus 350 t plus 100.
right. And
Yeah.
then you just work it out as a normal quadratic. Unfortunately, you may have to end up using quadratic formula to work out some of these quadratics. Um, but yes, exactly. It just becomes a lot of arithmetic and algebra. Actually, a real lot of arithmetic.
I was told there would be no math.
Yeah. Yeah, no numbers in this class, right? Um, anyway, all right. Well, there you go. That's a good problem. Any other questions on this one?
Can we go over what's called the notation? I'm sorry, I'm looking for it right now, but oh, jeez. For when we're finding domain and range, what do we call that notation again? It's
Set builder.
yeah, sorry, set notation, yeah. Um, for example, what is the the upside down V mean? So we have an example where the domain of F is X is an element of the system R of the set of real numbers R, and then there's a like an upside down V or like an up arrow Y. Is that
All
what is
right.
that? Yeah,
Where
sorry.
did
I'm
you?
looking at 10.6 example 5.3.
All right, give me a second here.
Oh, sorry.
Yeah, 10.6. I'm sorry, I don't see 10.6 on my list.
It's in the typed examples for
Oh,
yeah.
oh, in my typed examples.
Yeah, sorry. It's not there's no homework associated with 10.6.
Okay, hold on.
But
Let me.
will 10.6 be on the exam?
No. So
Oh,
this,
all right. Sorry then. Nope.
that's all right. Then, so it was was it this?
Yes, sir.
Okay. Do
Yeah,
you,
it's X, the funny looking E, um, R, and then that up arrow Y, and then the funny looking E, R, such that X is not equal to 0. So yeah, I can look that up on my own though. I'm
okay.
sorry. I didn't realize that
Would you
wasn't going
put
to
that
be.
on ed discussions?
Yes, sir.
Maybe make because I'd have to go searching for it. Um,
Here, I can share my screen if that
yeah, hold
helps.
on. Let me set it up so now you should be able to share.
Just opening the PDF. Sharing my screen. My, I'm sorry. How do I share my screen?
Uh, at the bottom, you see that green arrow says share,
Oh, yes, sir.
and then you select the
Mhm.
thumbnail. There you go.
Yeah. Okay. So, um, wait, I'll make it easy here. Okay.
All right.
So we're uh,
Oh,
this vet.
oh, you know what happened? Oh, okay. That,
Uh,
in my original notes, I just simply used a comma. And that means and. So the up arrow means, it actually means conjunction.
okay.
But in logic, it's a logical and connector. Um, I think what happened here, because you know what we did over Christmas break is we had to make everything ADA compliant. We had to go through every single document and um, make sure that anything that, so it was readable. Anyway, I think what happened was a lot of these symbols got altered a little bit. So I was, because I don't normally use that except if I'm in a logic question.
Mhm.
Normally I just use a comma,
Okay.
like I did at the bottom. You see more toward the bottom.
Yes, sir.
All right. Yeah, that's all it means. You had me kind of confused there.
Well, that makes two of us. All right. Thank you.
Sure. Well, guys, you have me for another few minutes. Is there any last questions you want looked at?
I just have a general test question.
Uh-huh.
I'm assuming that you're going to send an announcement out about this, so it's
Oh, yeah.
fine if you don't answer it. But how many questions is the exam going to be? And are they all fill in the blank, multiple choice? What should we expect exactly?
Well, I'll tell you what, I won't tell you how many questions it'll be, but I will tell you that it's going to be, if you do the entire practice test, you'll have done the entire test. Does that make sense? The test will be, questions will be chosen from that practice test.
Super helpful.
So now the practice test runs 43 questions. It's not going to be a 43 question exam. Um, but I won't tell you how many. It'll be enough to, I would imagine on average, most people will finish in an hour. You get two. Um, most people seem to finish in an hour, maybe 75 minutes. You don't need to rush things. It'll be just like your homework question. Some of them will be, select the right answer. Some of them will be numerical. Some of them will be um, maybe typing in an equation. So, but that practice test is a very, very good indicator of what the real test is going to look like. That's why I want you guys to do it.
Can we schedule a review session maybe for the 29th or the 30th?
Well, that's what I wanted to talk to you guys about. The 30th, if I'm mis it should be a Friday. Is that right?
Correct.
The only time I can do it would be sometime in the morning. So because I don't get in on Thursday night, I actually live 220 miles from campus. And on Thursdays after class, I start the drive back to my house and I don't get in until about 11:30. So I can't really do it on Thursdays. I can do it Friday morning. And so that's probably the best I can do. Can you guys maybe make a Friday morning? It's Friday morning my time. I don't know where it would be with your time.
Yes, I can do Friday mornings.
Yeah, and like always, I'll record them. Um, I've got people all over the world. So interestingly enough, I might get a different crowd Friday morning. That's the best I can do. I try to set the exams so that they usually fall either Friday, Saturday, Sunday, Monday, so that I'm here, so that I can monitor things. And but I also try to keep them consistent with the other sections too. So I kind of fell into that little gray area. So Friday, Saturdays when the exam goes, I'll send out an announcement about that probably on Wednesday. If I send it too early, people will ignore it. So probably on Wednesday, I'll send some information about the exam and a Zoom session.
Cool. Thank you.
Sure. All right. Um, Well, guys, if there's no more questions, I'm going to shut this thing down and I'll have it up on my page probably about a half hour, and I'll send an alert to all the people. Thank you for the good questions. And again, just keep on plugging away at this stuff. Put any questions to Ed discussions, and just hang in there. We're 2 weeks in, and we got 5 to go. So believe it or not, we're making good progress. All right, y'all. You have a good night, everybody. I'm gonna count this down. 5, 4, 3, 2, 1.